Today, I would like to discuss grease separators and how to properly connect the hood to recover heat. These solutions have moved from industry to single-family homes because they have become cheap. A proper grease separator for industrial systems will have UV lamps that break down the grease into small particles. But see how simple this one is. You can even make this on your own. A basic grease separator requires a grease filter. It's a metal mesh where the grease gets trapped and where water condenses because it is always a bit cooler. The next element in a grease separator is, of course, the drip tray. It is made of acid-resistant steel, although here acid-resistant steel is not necessary because there will be plenty of grease. So you have a natural anti-rust coating. And then we have a heat exchanger. We use aluminum ones. Why? In industrial applications, they should be aluminum. But in homes, even regular polymer ones might be enough. You would have to measure it exactly. It's all about temperature, yeah? Because here the temperature can be above 50 degrees and materials behave differently at 50 degrees. So here is a regular cross-flow exchanger. Can also be a metal counterflow one. And now look, we'll insert a regular exchanger here. I don't know if I should take it out, show you a regular cross-flow exchanger. Now I have to put it back in. Excuse my standing like this, but I have to insert it here somehow. I hope it works. Right, it's working already. And what's this about? We'll assemble our grease separator. We'll set everything up here so you can see. All right, we have it installed. Look, here we let our air from the hood pass through. When we set the hood to the second or third speed, it usually has a capacity of about 300 cubic meters. When the air is brought here by the hood, the first thing it encounters is the grease filter. Grease and water accumulate here. It has a drip tray here for it to flow down. Then it goes to the exchanger, and it is generally assumed that the flow from our hood is about 3 times greater than the additional flow we use here for cooling. That is the efficiency of the exchanger itself. A regular cross-flow one is, say, 50–60%. You can get 45, 55, 60. But if we supply 3 times more of this warm air from our hood, then the additional one for cooling, you could say the efficiency of our system, where we supply 3 times more of this air that we use from the hood than for cooling, is around 80%. This is useful for anybody who likes to cook at home. This is used in restaurants, in industry. I want to show you a few basic systems that can be connected to such a hood and that have the greatest efficiency. Look, the first system, it is not very inefficient. We connect the hood to the exhaust. We can say we recover everything from the hood here everything comes out nicely, but here we have a low level of water condensation. All this water goes to our unit, and the unit recovers all this heat. More water also condenses here. This is, let's say, an average setup. I wouldn't use it at home. And the next system, we don't use anything at all. These systems are rare in industry. I rarely encountered this. This system is very common in industry, although now that they are starting to calculate energy, they are moving away from this system because, look, we release all the water here, but to avoid cleaning the entire system, we send it to the exhaust. I often encounter these setups in high-rise buildings, say 10-story ones, nice, beautiful ones, where the exhaust is on the roof and you have to direct the entire outflow of this warm air there. Along the way, there are some fans that can supply and support this exhaust, also a rarity now. These were common back when energy costs weren't a concern. I would only use these systems at home if I had no other option. I would honestly prefer to cross them out, saying we don't use them at home. They are out. But here you have a nice setup. I'll turn this sideways so you can see better. Look, we have an air supply, an outlet, let's say dirty air from the corridor, exactly as described. And here we have our hood. Look, warm, humid air is coming in from the hood. Here, water condenses, grease and water. We cool the exchanger with the dirty air from the corridor. There should be directional dampers drawn here so that this air doesn't return. It goes to the exhaust from the unit. With this whole system here, you could say we recover about 90%, if not more. No? This would need to be measured under different environmental conditions, but let's say we recover between 80 and 90% of the air, the heat from this system. Honestly, this system is the best, and we recommend it for home use. This system is amazing. The next system we have is a specific one. It's the same as here, but we don't recover the heat. We just expel all of it outside. See the dirty air from the corridor here, but we don't get this system dirty at all, because the heat goes here, the water, the steam flows down, and the grease flows down. You get this in industrial systems where it's prohibited for the air from the kitchen to mix in any way. Every exchanger has its own tightness, and there is an allowance of 1 or 2% for the tightness. So we can always have 1 or 2% of that air mix in such an exchanger, and that's a natural thing. With counterflow and crossflow ones, that's no issue. The biggest issue is with rotary ones. With rotary exchangers, sometimes as much as 5% mixes. These are very popular systems known in the industry, which we use where there should be no possibility of dirty air mixing. Here we have a lot of water flowing, it cools down, the separator works very well, but we waste all the heat, it goes to the exhaust. Listen, the next very neat system is the fifth system. I encountered it in a well-known fast food place. We have a hood and we have an air supply. We direct the recovered warm air, which comes from the unit, to the separator, and then send this air to the offices, to the hall. I have encountered such systems a few times in large companies. These smells can also travel, which is very important. As I mentioned, the exchanger can transfer these smells at a level of 1 or 2%. Nah? So it's all about the fact that this incoming air recovered here, the warm air from our unit can transfer some of the smell, and we very often do it like this. We cool down the air from the hood, so here the efficiency of this system is very high. We pass this air through this exchanger,
through the grease separator,
and direct it to the building. And very often in larger companies with names starting with M or K, you know the ones, if something goes wrong in the kitchen, the management can immediately tell by the smell. Recently I saw that these systems are even used in hospices, so that people can get a faint smell of the food being cooked there to stimulate their appetite. To be honest, I would consider this system. I wouldn't use it in a home because it's a specific system. It's a variation of another system just with lower efficiency. In a home, I would use this system. It's perfect. We can use everything here. Look, a simple grease separator. Look how many connection possibilities it has, how much it can do. Once again, it is a very simple, primitive device, but it can recover heat. If a stove has, let's say, 3, 4, 5 kilowatts when we cook, then I know that with such a grease separator we can recover a lot. Let's say between 1.5 and 1 kilowatt. You heat a pot with a burner at 4 kilowatts. Obviously 2 or 2.5 kilowatts go into the pot and the rest goes outside. We can recover that with this grease separator, and it is done in large industrial facilities. I showed you a few solutions. This is the best solution for a single family home, and this is used in hospices or kitchens to intentionally transfer the smell so that the management knows what is being cooked, what's happening in the restaurant. That's all I wanted to tell you about the grease separator. It is a very simple device. You can even make it yourself because these grease filters can be bought in Poland. The exchanger, a simple box. You know, when I do this, there are labor costs, social security, and unfortunately it's not that cheap. But I think you can buy a filter for 200 zloty. You can buy an exchanger for 500-600 zloty. Assemble the box, connect it. I have to do tests, hire people, pay social security. So a grease separator made by me unfortunately costs around 1,200 or 1,400 zloty. A kilowatt hour of energy at home costs 1 or 2 zloty. So if you like to cook often, it's worth considering because it pays off. It definitely pays off in a restaurant just because of the cleaning of those entire systems. It will definitely pay off for you when it comes to cleaning. If you clean it yourself, then maybe it's so-so. But if you were to hire a company to clean the system, the whole exhaust, then it's basically one of the best solutions. As I said, you can recover heat using this. We will be making several models for different restaurants and institutions, and we will also be making them with a UV module. So when the hood is turned on, there will be a UV module that will break down the grease. I'm just wondering if it will be directly at the entrance to the hood. We'll see what's possible, what we can do, and we'll test it. That's all I wanted to tell you today about grease separators, a little known but useful device. I showed you the systems, discussed the 5 basic ones, the most interesting ones. The most interesting ones for us are number 6 and number 5 here. I wouldn't use the others at home. Thank you for today.